Hey everyone, it's Ken. I want to show you in this video the basics of summation notation, and what that is it's just a way to efficiently write down large sums. And the reason why we care about that is because we've seen in a previous video this left-hand endpoint approximation for the area or assigned area. In other words, you take an interval, a function defined on that interval, you're approximating the area under the curve perhaps, and you chop up the interval into equal pieces and pick up the left endpoints of each subinterval for your y values. And when we did that, we ended up with a formula like this. I'll write it down for you to refresh your memory. So it was something like the left endpoint of the first endpoint, the endpoints were labeled x0 all the way up to xn. So 0 to n, so n plus 1 endpoints for n subintervals. So that's the first y value times the common width, base times height. And then the left endpoint of the second interval, it's an x1, times delta x, and so on and so forth. And then you finally end up with the left-hand endpoint of the nth interval. That's f of x n minus 1 times delta x, and you add it all up together, and that's your left endpoint approximation. And we've seen some pictures of what we get when we do that. And the issue with this, other than that it just takes too long to write down, is that you see that ellipsis in the middle, that and so on. So what does that mean technically? So can we be more precise with that? So summation notation is a way for us to be a little bit more precise with what we're writing, and also more compact with what we're writing. So what I'm going to do, I'll just rewrite this expression and then I'll explain what it means as I go. So what we do is, let me rewrite this in summation notation. You use the Greek letter capital sigma. Think sigma for sum. And if you look at this expression, each term in that expression has a particular form, right? It's always f of something times the common width, delta x. And if I were to write down a general formula for that ith term, what I'm going to get is f plug in the ith, the left-hand endpoint for the ith subinterval. That's f of x I minus 1. So here for the first interval, it's 1 minus 0, f of x 0 times delta x. So what summation notation does is it gives you the general formula that you're going to use to find the ith term. It instructs you to sum, that's the sigma, and then the last piece that I need to figure out how to write this is what's the range of the i's. So in this case, I goes from 1 all the way up to n, signifying that I've got n rectangles. So you start out by plugging in I equals 1 to get f of x0 times delta x. Then you add to it, plug in I equals 2 to get f of x1, so on and so forth. And you stop when I is equal to n, so you end up with f of x n minus 1. So these two expressions are exactly equal. And in fact, there's multiple ways to write this in summation notation, completely equivalently. I could have gone from I equals 0 to n minus 1 and just written f of x sub I times delta x. So this is an expression. It's equal to the one that came before. It still has n terms, starting with 0 and ending at n minus 1. And but the formula is a little bit different. Instead of I minus 1, you've got an I, but that's okay because I starts one position lower. So that's basically how summation notation works. Just to give us a little bit more functional experience with it, I'll practice with a few more formulas. So what if I say sum of the number 1 from I goes from 1 to 3? Well, that looks kind of silly at first. So what's happening here? You're taking a sum. I goes from 1 to 2 and then to 3, so there are 3 terms in this sum. But the function, the formula you have, doesn't depend on I. So what you get is actually just the number 1 plus the number 1 plus the number 1, this turns out to be just a silly way of writing down the number 3. So this is just reminding us that the range of I is telling us how many terms that we're going to have. In this case, it was 3. Another thing I could do, let's come over here. Let's look at I goes from 1 to 4, and I'll just put an I there. So what about that? Well, in this case, I have to follow the rule. There's going to be 4 terms, I know that, and in each one, I'm just going to substitute I for what it's equal to. So I'll just get 1, and then substitute I equals 2 plus 3, and then after I get to 4, I'll stop. So this was just a formula that's a quick way of writing 1 plus 2 plus 3 plus 4, adds all that together. 4 plus 3 is 7, plus 2 is 9, plus 1 is 10. And, well, let's continue this a little bit. So what if I took I goes from 1 to n now for some fixed but arbitrary number n, like we had over there. And I want to sum up I. So once again, this is just going to be 1 plus 2 plus 3 all the way up to n. This is the sum of the first n numbers. And here's the question. What's this equal to? So is there a formula that you could sort of figure out that always tells you the answer? Something that I could just plug n into and get the answer, like I got 10 there. So actually, I'll show you the answer in another video, but for now, I want to let you just think about it. For this video, I'm really just introducing what is summation notation and trying to just give us a little bit of practice and experience.